Over the last 244 days, which is from January until August 2023, I've been collecting data on water service delivery in the UGU district municipality. We've all known that the water services are failing, but we haven't known the exact extent of that failure. So what I've done is I've been measuring just pressure. I have not been looking at water quality in the Southport area, which is part of the UGU district municipal supply. And I can now report on the following with a high level of accuracy. I can report that over 244 days, water has not been supplied, zero water supply for 37 days. And acceptable pressure has only been provided 59 days out of that, with less than acceptable pressure 146 days, or 60% of the time. So what does this mean? I've defined acceptable pressure as what is known as the minimum functional pressure for electrical appliances to work. So anything below that pressure, which is 2.5 bar, anything below 2.5 bar pressure at the incoming main is water. It's considered to be a flow, but it's below the acceptable functional pressure. So in effect, it's dysfunctional. The service delivery is dysfunctional. So from that, we can say that UGU, over an 8-month period in 2023, has only provided water to the acquired assurance of supply for 15%. So that's a 15% service delivery. 25% of it has been acceptable, in other words, in excess of that minimum functional pressure of 2.5 bar. But 60% of it has been a failure because it's been below the minimum functional pressure. So while there is a flow present for 60% of the time, it's inadequate to enable electrical appliances to work. So dishwashing machines, washing machines and stuff like that are unable to function with that low pressure. So therefore it's not effective. So if we go into the data, and we can now start looking in greater detail from 1 month to the next. If we look in the month of January, we see that 49% of that month was a failed delivery, failure less than 2.5 bar, which means only 51% of it was an acceptable flow above 2.5 bar. 2 days had absolutely no flow at all. 12 days had a pressure that was acceptable, in other words, 2.5 bar and above, and 12 days low pressure. So this information starts feeding into our engineering design as we start looking at possible solutions going forward, and I'll expand on that as we go through the different data over time. When we get onto February, we see a slightly different pattern occurring. In February, we had 93% failure, as in less than the 2.5 bar. Only 7% acceptable flow, which in fact was just for 2 days, above 2.5 bar, which left 3 days of zero flow, absolutely no flow at all. 2 days of pressure, of acceptable pressure, and 23 days of low pressure. So we can start seeing that the pattern that is emerging now is not really one of no flow, but rather a pattern of low flow or inadequate flow. And this trend starts expanding as we go forward. In the month of March, we had a 90% failure. 10% of the time water was at an acceptable pressure on or above 2.5 bar, which is only 3 days of the month. we had 3 days of no pressure, of absolutely no flow, but that was broken up into 2 batches of 1 day and 2 days, so the duration was relatively short. And we had 25 days of low pressure, or less than 2.5 bar, which is the minimum functional pressure. So from now we can start to see that the problem that we have to start designing for is not so much a zero flow situation, but more a situation of an erratic supply or a less than desirable pressure. So we need to start thinking of on-site storage and boosting pressure rather than having to find alternative sources of supply. This trend continues into April, where we have a 100% failure. So every single day in April, we had water delivered at less than 2.5 bar pressure, the minimum functional pressure for appliances to work. But of those, we had 0 days that we had no flow. So there was zero. At no time did we have low flow. The lowest flow we had was 0.5 of a bar, but we still had water at that low pressure. And so we had 30 days of low pressure. So here we can now clearly start seeing that the problem is not the non-availability of water per se, but rather the non-availability of pressure. So once again, our engineering solution now starts coming more clearly into focus as we need to start designing more for on-site storage to capture the low flow in off-peak periods for use in peak periods. This trend will continue. As we now look at the data from May, we start seeing the same kind of trend. Of the entire month of May, we saw a 70% failure. 30% of the flow was acceptable at 2.5 bar and above, but we only had 3 days of zero flow. So once again, the pattern was 1 day of zero flow, followed by a couple of days of high flow or normal flow, and then 2 days of no flow at the end of the month again. So once again, we're starting to see more texture coming to the data now, and this starts refining our engineering design for solutions going forward. When it comes to June, we go into a very distressing month because the last 2 days of May, there was zero flow. And now we start going into the first 9 days of June with zero flow. So that gives us the longest period of continuous zero flow. And that's a very important engineering design parameter, because that tells us when we are planning for our strategic storage on site, we need to start looking at something in the order of 12 days of zero flow. But then what's interesting is we start seeing the flow return for a few days, and then it collapses again. And then there's an attempt to restore the pressure, and then it collapses again. So this suggests that there is possibly sabotage taking place in the system, because each time the system is repaired, there's some other action that is brought about, something fails in the system, and pressure is lost. The important thing is that in the month of June, as bad as it was with the longest continuous period of zero flow, we in fact did have at least 6 days of acceptable pressure. So once again, if you can capture water in those periods of flow, even at low pressure, and store them on site, you can start surviving these long drawn out periods without water. This trend continues over the entire data set. July is also a bad month. 87% of July saw failure, total failure of service delivery. Only 13% of the month was favorable or acceptable service delivery with water above the minimum functional pressure of 2.5 bar and above. But what we see there now is we had also, once again, 9 days of zero flow, but it was not continuous. There was a little spike in that 9-day period. So effectively, if you had storage on site for a 10-day period of time, you would have survived that. In fact, you would have survived it for even longer if you could harvest that little bit of peak flow coming through in the first quarter there. So the solution is now starting to become more clearly focused. It seems to be less about having to get a borehole, which is a very expensive item, and more about investing your capital into a strategic storage on site to enable you to survive a 10 to 12 day period of no flow. August merely continues the trend that we've already seen. The early part of August saw a period of very, very low flow, but there was some pressure, 0.5 bar. If that can be captured off peak, then you can get through your peak periods of time. So over the month of August, we see an interesting spread, because an 84% failure, 16% of the time we had acceptable flow. Only 5 days did we have no flow, zero flow. And 21 days we had a low pressure, and only 5 days acceptable pressure. So from this, we can now start aggregating our data, and the aggregated data tells us that of the total period of failure was 81%, 81.6% of the time was a total failure, which means that we've in fact got a 20% service delivery. That's what it comes down to. And the engineering design for potable water in South Africa, as defined by the building standards and by the formal officially recognized standards, is a 98% assurance of supply. So 98% of the time we're supposed to have water, which means that you can have one breakdown in 50 years. That's what it comes down to. And we are having, we're having multiple breakdowns in any 1 month. So we are as close in UGU to seeing systemic failure as you are likely to find in any part of South Africa. But even though we have systemic failure, we still do have some flow in the system. So the problem is not necessarily about finding an alternative source of water. It's more about having to invest into infrastructure on site to store water for off-peak use. So store water that's coming through in the periods of low flow when the demand is also low, and then boosting that pressure for when it's needed. That's what it comes down to. So the solution is an uninterrupted water supply, which requires sufficient storage on site for a period of up to plus minus approximately 10 days. If you can have on-site storage of water for 10 days, with a booster pressure pump, then you are going to survive the current state of failure without having to invest a significant amount of money into drilling a borehole. My name is Anthony Turton, and I hope that you found this information to be of some use.